Quick question. Have you ever built something on your laptop, watched it run perfectly, sent it to a teammate or pushed it to a server, and it just broke? No code changes, same files, different result. Every developer has said this sentence at least once. Well, it works on my machine. That one sentence has cost companies millions of dollars in downtime, wasted engineering hours, and way too many 3 a.m. emergency calls. Back in 2013, a small startup got so sick of that problem that they built a tool specifically to kill that sentence forever. That tool is Docker, and by the end of this video, you'll understand exactly how it works, why practically every tech company on Earth runs it, and why in 2026, it just became more important than it's ever been. Let's get into it. Here's the problem. Software doesn't just need code to run. It needs an entire environment around that code. A specific version of Python or Node or Java, certain system libraries, specific file paths and settings, dozens of tiny details most developers never even think about because their own computer already has all of it quietly sitting there. The second that code moves to a different machine, a teammate's laptop, a testing server, a production server in some data center you've never seen, none of those details are guaranteed anymore. Different operating system, different library versions, something's missing. And suddenly, your perfectly working app is throwing errors nobody can explain. For years, the fix was painful. Write a setup document. Hope your teammate follows every single step exactly right. Pray the production server matches your local one closely enough. It didn't really work, not consistently. Docker's idea was simple, but genuinely clever. What if, instead of shipping just your code, you shipped the entire environment that code needs, packaged up together, sealed, and guaranteed to behave exactly the same way everywhere? Picture it like this. You're a chef. Instead of handing someone a recipe and just hoping their kitchen has the right stove, the right pans, the right ingredients, you hand them a fully stocked, ready-to-go kitchen. Same stove, same pans, same ingredients, every single time. Doesn't matter whose house you're cooking in, the result is identical. That sealed, portable kitchen is a container. So how does Docker actually build one of these? 3 things you need to know. First, a Docker file. It's just a plain text file, a list of instructions. Start from this base, say a lightweight version of Linux. Install this version of Node. Copy in my code. Run this command to start the app. It's literally a recipe written in plain steps. Second, Docker takes that Docker file and builds an image. An image is a frozen snapshot, a sealed, read-only package containing your app and absolutely everything it needs to run. Nothing missing, nothing extra. Third, and this is the part that trips people up, you run that image, and it becomes a container. If the image is the recipe turned into a sealed meal kit, the container is that meal kit actually being cooked, live, right now, doing its job. Run that same image 10 times and you get 10 identical, isolated containers, each behaving exactly the same way, whether it's on your laptop, your coworker's laptop, or a server on the other side of the planet. And here's the part people love. These containers are lightweight. A full virtual machine basically simulates an entire separate computer, which is heavy and slow. A container shares the host machine's operating system underneath it and only packages the parts that are actually different. That means containers start in seconds, not minutes, and you can run dozens of them on hardware that would completely choke trying to run the same number of virtual machines. One more piece worth knowing. Once you build an image, you don't have to keep it to yourself. Docker Hub is basically a massive public library of pre-built images. Need a database? There's already an image for that. Need a specific version of Python and fully configured. Someone's already built it and uploaded it. You just pull it down and you're running in seconds instead of losing an afternoon to installing dependencies. Now here's why this matters more right now than it ever has. Docker isn't just for shipping web apps anymore. Through 2026, it's quietly become the backbone for something much bigger, AI. Companies are now using Docker to safely run AI agents. The kind that can write and execute their own code inside sealed, isolated containers. So if one of those agents does something it shouldn't, the damage stays contained instead of spreading to your actual machine. Docker has already partnered with at least one open source AI agent platform this year. specifically to sandbox agents this way. And security has become the other big story. Supply chain attacks, where malicious code sneaks into software you depend on without you ever knowing, have exploded. One recent industry report found that the vast majority of organizations dealt with a software supply chain security incident in just the past year alone. In response, Docker opened up more than 1,000 pre-hardened, security-scanned images completely free, so developers don't have to build safe environments entirely from scratch anymore. So Docker isn't just solving "it works on my machine" anymore. It's becoming the security layer standing between your code and, increasingly, AI agents acting on their own and total chaos. So next time someone tells you to just Dockerize it, you'll actually know exactly what that means. Build the image, run the container, ship the exact same environment everywhere, every time. If this video helped Docker finally click for you, consider subscribing. Every another day, I break down another developer tool in plain English, so you can spend less time feeling confused and more time building things that actually work. And drop a comment. What should I break down next?